Hi class, welcome to Unit 1 review. As every student has been provided with a review sheet includes major understandings listed above and practice questions to practice the big ideas taught in this unit. The document displayed represents the answer key as provided on Pupil Path. So of course we're going to go through the answers together in this video, but if you would like to fast forward, you can simply access this document on Pupil Path under the study homework number 10. In the first question, we are asked for a substance that can be decomposed by a chemical means. So recall that when we look into matter, let me pull it up. Matter can be classified using this diagram. It may include either a pure substance or a mixture. Now, of course, under the pure substances, we have elements which cannot be decomposed. We have compounds which can be separated, and their separation is chemical. So a chemical separation is going to require that a bond is broken. So we can see here in the element section there are no bonds, so these cannot be separated in any ways. In the compound section, there's bonds, in this case between the red and blue particle. So in order to separate the red and blue particles, a bond is broken by chemical means. And then here we can see mixtures, because the different components of a mixture are not bonded, they can be physically separated. So here, by chemical means, that should remind us that we are looking for an element. So what we'll need to do is refer to our periodic table of elements. Now, instead of looking at the simple periodic table of elements, we're going to refer to table S, the table of selected elements, so that we can verify the existence of elements. Okay, so we've pulled up our reference table S, and on reference table S, we have the names, symbols, and atomic number of all of the elements. Here we can see that element number 74 is tungsten, element number 36 is krypton, and element number 51 is antimony. When we scan all of the names on reference table S, the name we cannot find is methane, because methane is actually a compound. So here the best choice would be methane. The next question asks us which is a pure substance. Now when we look up at our matter chart here, we can see that pure substances include either elements which contain only one type of atom or compounds. So when we look at the particle diagrams and we circle the different components, you can see that component A only has this compound. It's considered a compound because it has two different particles, a small closed circle and a larger open circle. Now in the other pictures we can see multiple components. So B is not a pure substance, but it's a mixture because it has this small closed circle and this larger double circle, and these are different particles that are not connected with a bond. Again, we can do the same in C, and we can do the same again in D. So the only diagram that has a picture where there's only one type of particle, either an element or a compound, in this case a compound, is A. Now in question 3, we're looking for a substance that can again be decomposed by a chemical means, which from question number 1 we now know that means that we're looking for a compound. And substances that cannot be decomposed by chemical means would be elements. So again, we're going to look at our reference table S. And here we can see that element number 8 is oxygen. Element number 15 is phosphorus. And element number 14 is silicone. So these three substances are elements, so ammonia is not listed anywhere on this table. Therefore, ammonia must be a compound. Now in question 4, we're again asked to look for a compound, but this time we're given formulas. Now when we look at reference table S and we notice all the formulas of elements, we see that the formula of an element always begins with a capital letter and may have 0, 1, or even 2 lowercase letters also in its symbol. Compounds consist of elements chemically combined, so compound formulas will have 2 or more capital letters. That's why carbon monoxide is the best choice. The next question asks what technique can help remove salt from a mixture of water. Now, this is requiring you to use a little bit of your common knowledge that salt dissolves in water. So when something dissolves, it creates a solution, and anything that is completely dissolved can never be filtered. So filtration is not a possibility. Now, again, common sense should pretty much tell you that evaporating the water, would be a really good option in this case for separating a dissolved solid from a liquid. Paper chromatography is a separation technique, but it's commonly used in inks to separate based on the ability to dissolve within a solvent and also the ability to attract to a piece of paper. And density determination, that wouldn't be very helpful again in separating this mixture. Question number 6, we're looking for a mixture of substances. So we briefly just talked the phases of matter of solid, liquid, and gas, but the phases of matter just refer to the arrangement of particles. The word solution actually refers to a homogeneous mixture. So solution here, just based on simple vocabulary, is the best choice. Question number 7 asks how to separate a mixture of 2 alcohols, rubbing alcohol and isopropyl alcohol, in water, and they use the term here distillation. And every time we see distillation, we basically understand that this is a boiling process. So if you're going to separate 2 things with distillation, they must have different boiling points. So that would allow us to eliminate 2 of the choices immediately. Now, the reason in which choice C is the best choice is because when we have a mixture of things, they are not chemically combined, and so they maintain their individual properties. And that's what allows us to physically separate with distillation. If the substance was chemically combined, the whole substance would likely have a one boiling point, and you would not be able to separate without a chemical means. So you can only separate chemical combinations with chemical means. In question 8, we were asked what can be decomposed by a chemical change. And if we refer back to our matter chart, we recall that the chemical change or the chemical means of separation directly correlates with the compound. So here we're essentially going to be looking for a compound. Now recall from our reference table S that has elements, that elements have just one capital letter and 0, 1, or 2 lowercase letters in their formula. And compounds will have 2 or more capital letters, and that's why carbon monoxide is the best choice. Question number 9 simply asks us, what is true concerning elements? And all elements of the same, all atoms of the same element have the same atomic number, as we can see here on reference table S. Question number 10 asks us to look for a substance that cannot be broken down by a chemical change. So you can recall that that substances that cannot be broken down by any means would be the elements, and substances that can be broken down by chemical means are called compounds. So here, since we cannot break them down, we're looking for an element. Elements are found on reference table S. And arsenic is actually element number 33. In question number 11, we are looking for elements of only one compound. So we're looking for in the gaseous state. So only one compound means that we're looking for a pure substance, only one type of particle. Now when we look at the particles, we call that elements have one type of atom, and compounds have 2 or more types of atoms chemically combined. So in choice A, I see that we have the element circled here in blue. That is a triatomic element. Now in choice B, we have a mixture of elements. We have a diatomic element of open circles, and we have a diatomic element of closed circles. So this is wrong because we have no compound, and we actually have a mixture of elements. In choice C, you'll notice that we have a compound, a chemical combination of 2 or more different atoms. So choice C is going to be our choice, and the reason why choice D is not our choice is we do have this compound here, but we also have a different compound present, so that's a mixture of compounds. So choice C would of course be the best choice.